Hello and welcome to the AK Podcast, where we explore science and nutrition behind livestock care and management with the best and the brightest in the business. Today, we're having a special podcast. I'm your host, Chris Radke, part of the sales team here at Agri-King. And with me today, as usual, is Mr. Mike Donaldson, who is part of our Director of Field Services and a member of the sales management team. Mike, how you doing, buddy?
Very good. Thank you, Chris.
All right. Who do we have with us and what are we going to talk about?
Well, this is one of our first actual, Chris and I called it a special edition. Something's going on right now in the dairy industry, especially that we want to give some time to. Today, we're joined by Dr. Marcus Kehrli. Marcus is a member of the board of directors at Agri-King. He grew up on a diversified farm in Iowa. Had a very fascinating career, gone down a couple different paths. I'm going to ask him to fill you in on that, and then we'll get down to the topic for today. So, Marcus, tell us about how you got to where you are.
Well, thanks, Mike. Appreciate this opportunity to visit about a very important animal health issue today. As you said, I grew up on an old-fashioned mixed livestock and crop farm. Grew up with my parents and grandparents. We crop shared together, and we had a small herd of dairy cattle, milking 20 to 40 cows at a time. We had a few beef steers every year, primarily for local consumption, if you catch my drift. We had another small fair to finish swine herd. I think we peaked at about 70 to 90 sows twice a year. And then a flock of laying hens on our farm and one on our grandpa's farm. And since I was the shortest ones, I always got an opportunity to clean out underneath the roost. And then a flock of sheep. My dad liked ducks. We had ducks and geese. And I know you always seem to have a turkey that disappeared before the end of every November. Not sure how that happened, but I know Dad had to climb to the top of the windmill one year to bring him down. I was active in 4-H and FFA, showing dairy cattle and raising hogs on FFA projects. And I always had an interest in science and medicine. And that began in high school with the FFA, when I conducted a couple of research projects. First one was evaluating the use of high lysine corn as a seed that we planted and harvested. And we then the next year, I did a rate of gain comparison against standard corn in a group of hogs that I owned. So that was my first experiment. And then just before I went off to college, I collaborated with our local veterinarian. We had a flock of sheep, and we wanted to manage the lambing season. So I developed these intravaginal pessaries, and we did some hormone implants via them. And that one would have been my first failed experiment, one of many. But as it turned out, it was all a good learning process and a lot of fun. After high school, I went to Iowa State University, where I earned my degrees in dairy science and another one in bacteriology. And that was all before I got my Doctor of Veterinary Medicine degree there. Before I graduated from vet school, I had a unique opportunity presented to me to explore a career in mastitis research in dairy cattle out at the USDA's National Animal Disease Center, which is a part of the Agricultural Research Service. So I ended up taking that position, and I earned a PhD in immunobiology, also from Iowa State, while working full-time for you as a taxpayer. And my research focused on the immune health of transition cows, which, having grown up on a dairy farm, I knew that was a very important time period. And then my research continued in the areas of inflammation. We did some genetic differences in immune health research, collaborated with an animal breeder at Iowa State, a world-renowned gentleman who was a great collaborator. So I published on a wide range of dairy cattle immunology topics and genetics, all focused in the context of improving mastitis control in dairy cows. After 16 years of research at NADC, Mike, I went on and had an opportunity to join a pharmaceutical company where I led some research for 5 years. At that point, it was a very unique experience. We investigated projects with dairy, beef, and swine, all in search of novel therapies for unmet medical needs in veterinary medicine. And some of them were for treatment, some of them were, preventatives for both infectious and metabolic diseases. So that was a great opportunity. And then with all the reorganizations that happened with mergers and acquisitions in the pharmaceutical world, I was presented with an opportunity to return to a leadership role at the National Animal Disease Center back here in Ames in October of 2003. And that's when I began as the research leader for the virus and prion diseases of livestock research unit at the National Animal Disease Center, which is probably why you asked me to join you today, since we have a virus that's going to be the center of the topic. Over the next 10 years, I took that job. I had the privilege to lead an extremely talented and highly productive team of scientists for nearly 10 years. And over that period of time, our research team responded to several emerging diseases, either around the world or right here in the good old US of A, including mad cow disease, or BSE, otherwise known as the tongue tangler, bovine spongiform encephalopathy. And there will be a quiz at the end on the spelling on that, Mike.
No quizzes.
All right. Well, chronic wasting disease in wild cervids is another prion disease. And then we also dealt with numerous swine viral diseases, including but not limited to porcine circovirus. We had the H1N1 of 2009, just a wealth of viral diseases. There was Seneca virus A that really caused some chaos. So there was a lot of fun working with those projects. And so our work with influenza is probably why I'm here today to talk with you. Just as an information, the National Animal Disease Center is the USDA ARS largest animal health research facility. It's a biocontainment facility capable up to what's called BSL-3 Ag, Biosafety Level 3 Ag. And that's like putting a bison or a steer or an elk or a deer right inside of a biological safety cabinet, only it's a whole lot bigger. And it's a completely unique building in the world. There's only a handful, and literally you would have a finger or two spare to count facilities in the world capable of that type of research. So it was a great experience, and it's a great resource for the United States and the world. After I retired at the end of 2020, as you know, I was asked to join the Agri-King Board of Directors, which since that point in time, I've had the pleasure of serving on since July of 2021.
Well, thank you for the rundown, Marcus. I'm glad I didn't try to do that myself. You've accomplished enough for several lifetimes. You've alluded a couple times, and it is the current version of avian influenza that we'd like to talk about today and get some information out for people. Could you take us through, what is this current version of avian influenza, and just start trying to put some fact where right now there might be some fiction and strange stories going around?
Well, I'll try to keep it right down to the facts as I know them. And so today we're going to focus on the avian influenza virus strain that's currently circulating and infecting cattle. Scientists refer to it as a high-path H5N1 virus. It has a whole list of numbers after its name that break it all the way down to the exact virus that it is. I'm not going to get into that. Now, you might find this interesting, Mike. Avian influenza viruses, have likely been around for a very long time, as there are reports of an avian influenza outbreak. They called it fowl plague back then, as far back as the late 1800s in Europe.
Really?
However, that was long before we had any knowledge of viruses as pathogens, and much less our modern-day genetic sequencing and PCR technologies that help us to very rapidly identify, sequence, and understand these viruses for what they are. And as it's go ahead, Mike.
This is nothing new. This is just
correct. They've been around for eons, I'm sure. We just didn't know how to measure and detect them. Now, the virus today, the very specific genetic sequence of it is unique, but migratory waterfowl have had these viruses probably forever.
Okay.
So, as its avian name implies, this genetic group of highly pathogenic avian influenza viruses, it's a natural reservoir in these aquatic wild birds. And they primarily infect the intestinal and respiratory tract of these birds. And I'll get into some more detail on how that might change. As a result of being in those tissues, the virus is shed into the environment where other hosts may encounter it, and they will then thus become exposed and possibly infected. So typically, these viruses also start out as what we call a low pathogenic avian influenza virus in migratory waterfowl like ducks, geese, and swans. As a low path virus, these birds experience no or only mild signs of disease when they're infected and carrying this virus, but they nonetheless carry it and shed it into the environment. However, eventually these low path viruses will spill over into domestic poultry and begin to circulate in a flock, and it will continue to mutate in the domestic birds. And when certain mutations end up happening, particularly in one example is with the hemagglutinin or the H gene, and that's where the H5 gets its name from. It's the hemagglutinin number 5 gene. And when certain mutations occur in that H gene, they can allow the virus to infect tissues in birds beyond the respiratory tract and beyond their intestinal tract, meaning they become a systemic infection in those animals and damage a lot of tissues. They may go to the brain. You name it, they can get there. And those mutations will convert this into a highly pathogenic virus. In fact, the definition of a high-path AI virus is that it causes very severe disease and high mortality rates in domestic poultry, typically leading to death in less than 48 hours. In fact, they have an index that they'll rate them on how fast they will kill them. And, there's a range even under those 48 hours. So that's how they get the high-path name.
Where is it believed that this current version originated? What kicked this flavor of the month off?
Well, this flavor had a lot of heritage prior to the recent developments, and I'm just going to touch on that a little bit. The first report of high-path avian influenza viruses, the H5N1 in particular, was in 1996 in Asia. And since then, these viruses have spread around the world via the migratory flyways of waterfowl. Now, you might ask why I'm talking about this and why is it important? Well, with these long-distance migrations, the birds will congregate in high densities at their breeding and stopover sites during the migration, such as the Siberian wetlands. These are breeding grounds for many waterfowl species, and the various coastal estuaries and inland lakes along these flyways, which may serve as resting and feeding sites during the migration. So a lot of commingling of birds. These migrations in the northern hemisphere will end up in the northern polar regions of the globe. And there they can be a lot of mixing of birds from the convergence of different flyways around the globe. Hence, these locations can serve as a mixing bowl where birds from different regions interact. These interactions include shedding of the viruses and acquiring viruses through the fecal-oral transmission route in shared water sources, which obviously they're waterfowl, they're going to be in water. These interactions will lead to a frequent exchange of viruses that will also enable the reassortment of the viral genome segments. Now, I didn't mention it before, but influenza viruses have 8 gene segments or genetic segments. They have a couple of genes on a few of these segments. So it adds up to more than 8 total genes. But when a bird is infected with more than one virus strain, each virus brings in 8 gene segments into there. And as they begin to replicate the viruses, they can swap back and forth some of these segments. Not all combinations work, but when they do, you can get the emergence of a new virus. And that new strain might be more virulent or more transmissible, not necessarily more virulent. It's not usually in the best interest of a virus to kill off all of its hosts because then it's a dead-end virus. It's to the advantage of the virus if it wants to survive, not to kill everything. So as some of these birds continue to migrate back to their equatorial regions of the globe, as they continue this cycle, there can be further commingling of birds when they arrive in the equator regions, because there they're going to meet up with migratory waterfowl from the southern hemisphere that do the same thing, but they go south instead of north when ours go north. So, as you can see, there's ample opportunity for these RNA viruses, which influenza is, to evolve through mutations, which we call genetic drift, and those are single-point mutations. And they can also exchange genetic segments, which we call genetic shift. So drift and shift can lead to a lot of variability in these viruses. the successful drifts and shifts of these viruses will eventually move around the globe through the transmission of these migratory waterfowls from various origins. Not all of the mixing works, and some of these viruses die out, but some will be sustained. And it may take a couple of years for them to spread around the globe. But back to this high path H5N1 in cattle, it's a great example that this mixing does occur, and it went from Asia and eventually is global. Now, the topic of the one that's getting into cattle, these are viruses that spilled over from infected birds into cows and other mammals more recently. And scientists have a very specific way of naming these, but there's a very short numeric designation on these particular strains that we're getting out of cows and more frequently from mammals recently, that we're just going to focus on them at this point on. So their unique genetic makeup that makes them able to infect various mammals and birds. Now, this is because that hemagglutinin has evolved through some drifting of the genetic sequence to be able to bind both avian and mammalian receptors for the influenza virus. You can think of it as a lock and key if you want, but the receptors differ when they're in mammals like us, or cows, or pigs, or whatever other mammal they're in, than they are in birds. It's a difference in the chemistry. It's a very subtle difference, but it's a big impact on receptor binding. So, some of these viruses had enough of a drift that they kind of are able to latch on to the mammalian receptor. And this promiscuous receptor binding allows them to infect and then get into the animals, and they will continue to mutate every time they go into a new species, and that allows for further adaptation. Now, sometimes that results in more efficient transmission in that new host species, but not always. So at this point, I want to emphasize that this particular group of high-path H5N1 viruses do have an expanded host range, including, but not limited to cattle. It includes wild and domestic cats, and in fact, on some of the dairies where this was first reported, all the cats on the farm were dying because they were drinking unpasteurized milk or unpasteurized colostrum being produced on the farm from infected cows. Those cats had very severe disease, and the way the virus infected in those cats, it went to the brains on many of them. So that might be a sentinel sign on a farm where you might start seeing dead cats even before you see serious health issues in your cows. They've also seen this in wild canines, fox. I've heard reports of wolves, you name it. Wild animals that probably came across a dead bird in the environment in the wild, and they consumed it. But that dead bird may have died from this particular strain. Skunks, raccoons, marine mammals, seals are dying from these. And in some instances, we've had human infections. Now, there have been no mortalities from the virus that's in cattle, per se. There's still some parent strains circulating in birds, and there has been one human who was infected that did pass away, sadly. And that individual was a little bit elderly, a little bit younger than me. It was reported they had some underlying medical conditions that probably made them much more vulnerable to the severe effects that they experienced. Now, the ancestors of these current viruses are thought to have reached North American continent on both the east and west coast almost at the same time. So it was coming down on different flyways almost simultaneously. So that's a good example of how those breeding grounds up north enabled the spread of this parent virus that first emerged clear over in Asia. Now, here's the other thing. Scientists now believe, based on genetic sequencing, that at some point in 2023, that is when this parent H5N1 that was circulating the globe also reassorted with a low-path AI virus that ended up resulting in this particular genotype that's now spilling over into mammals, including cows. So there was another, that one was actually some genetic shifts where they exchanged some of the gene segments from other low-path viruses to make this H5N1 more able to not only infect, but to replicate. So that's a little bit of the background on that. Now, less than a year, there has been quite a bit of research done. So research since March of last year has shown that the mammary gland of cows has a very high prevalence of the avian receptors. Who'd have thunk that, right? And those receptors in the mammary tissues, even in the cells that produce milk and the milk ducts coming right from them, they all seem to be very able to be infected by the virus. And that has been shown by the team of diagnosticians and scientists that first worked with the herds down in Texas. They were able to demonstrate that, and they did some elegant studies to show that those receptors existed. And there have been other studies since then under high biocontainment that are controlled studies, and those have found the same results. So the mammary gland seems to have a lot of receptors for these unique high-path avian influenza viruses, and that results in the mammary tissue damage during the course of the infection, the reduced milk production, scar tissue forming in there, has a dramatic impact on milk production. And obviously, milk is the bottom line for dairy producers. That's how they make a living, and it's one of nature's most perfect foods. So we don't want that happening. Clearly, more research is needed for us to understand how this virus is spreading within herds. The research is, I'll say it's a little bit confusing because we would think that we'd be able to rapidly identify the mode of transmission between cows, but that has not been real straightforward yet. So there have been experiments done in high biocontainment conditions. There was a study by a team of scientists down in Kansas State and in Germany, and then another set of studies done at my former employer out at the National Animal Disease Center by scientists that do a lot of influenza research in pigs. So they have tremendous expertise in working with influenza, as well as the facilities do a lot of very unique things in the highest level of biocontainment that you can use. So what they found is that you can take the virus that you've isolated and grown up in tissue culture, and you can put it up through the teat end like you're treating the cow for mastitis with an antibiotic. But only difference is you're putting the virus in, no antibiotic.
Okay.
That will infect that gland. And the early studies say it stays in that 1/4 on a cow. It doesn't even spread, which is very unusual to me. But that's what they're finding.
Blood kind of goes everywhere. You would think it would.
You would think, and the mammary gland gets a huge percentage of the blood flow of a dairy cow because you need a lot of blood to produce milk. So, all those nutrients that the blood supply delivers into that udder is very important. And you would think that we'd have a short viremia where the virus gets into the bloodstream and spreads elsewhere, but we're not seeing that. Now, as you know, Mike, the cow has a ligament that goes between the right and the left half, and that has always separated the right and the left side of the cow's udder from each other. But there is communication front to rear on the same side. So it's just caught me a little off guard that it's not spreading to other quarters. And we need to know more about what's going on in the commercial setting where these animals are probably getting infected by a different route. Because in the experimental studies done in biocontainment, when they've taken like a broth of the virus in media and covered the teat, the skin of the teat, the outside, they've not been able to infect the cow. Now, the other thing that they've been able to do, both the two experimental groups, one's here in Ames and the other's between Germany and Kansas State that collaborated, they can squirt it in the nose, but we also, at NEDC, we had a team of scientists that developed a way to nebulize viruses and bacteria to spread any pathogen that you're working with deep into the lungs of cows, or in fact, the techniques were originally developed for use in tuberculosis research in deer and cattle. And it causes a much more normal appearing infection that you see in the wild, if you will. And that does work to spread this virus. So the point is, you can transmit the virus through the aerosol route, but we have not consistently detected shedding of the virus from infected cows that were originally infected by aerosol spread. So whether there's nose-to-nose spread, we don't know yet. And we're, working in biocontainment. Level 3 biocontainment was never designed for a dairy cow, and much less a dairy cow producing 120, 130 pounds of milk twice a day or every day, twice a day milking. It's just, it's a very difficult environment to work in. Plus, for various reasons, the researchers, we have to wear full face properly fitted respirators or N95 respirators, which, they do work, but you have to be properly fitted. And you and I, with our facial hair, probably wouldn't be able to get fitted. So in any case, those studies, we can definitely infect the animals. We see the severe mastitis, no matter whether they were done in Germany or Ames, Iowa, or Manhattan, Kansas. So it seems to be some consistency there. The milk has large quantities of the virus when those quarters are infected, and you can easily detect it. Now, the good news is a team of scientists that work with avian influenza down in Athens, Georgia, they very quickly came out and used pilot-scale commercial milk pasteurization units to demonstrate whether or not pasteurization inactivates this virus. It easily does. So our commercial milk supplies that are pasteurized are safe to drink. That's a great news. But until that product gets pasteurized, it poses a risk. And that's probably why some of the milkers and workers around the cows have gotten infected. And typically they've been infected in the conjunctiva of their eyes. So it's an area of vulnerability. I grew up milking cows. I understand that the personal protective equipment around a cow usually is your best thing is your reflex to get out of the way of a swift foot or a tail.
Yep.
But in this case, you need to be able to avoid eye splashes, or milk squirting up into your mouth or anything like that. And that's much more challenging and cumbersome and much more difficult to implement on a dairy. So I totally understand why there's very low adoption of wearing personal protective equipment like that while milking cows. It's uncomfortable, it's hot, it's inconvenient. You get sweaty, you can't see, it fogs up. It's just a real challenge. Now, go ahead, Mike.
I was going to say, so you kind of, you've touched on some things. I might go back, and it might sound redundant, but to just get a little more clarity, what is making this specific version of an avian flu virus concerning right now? I mean,
well,
if they've been around for 200 some years. Some seem to be a big deal, some not so much. But this one is, I mean, by what you said, the fact that it can go into a mammal makes it different. What are the next things we're afraid of happening?
Well, clearly the thing that most the influenza researchers in the world and the public health officials are worried about is this evolving into a virus that transmits much more readily than it currently does. And that could be something that could happen through continued mutation or maybe another genetic shift. And that would lead to another pandemic, which is the last thing on planet that we need right now. So as a group, this particular group of influenza viruses is infecting a wide spectrum of animal species around the world. And as I've said, the parent virus has been around forever. They're in so many different species that eradication is not a practical goal. We have eradicated smallpox from the human population. We have eradicated rinderpest from ruminants. Those are two massive accomplishments. We were on the verge of, eliminating or eradicating polio, but we're not there yet. So getting influenza out of the world is just not a practical goal. There's just too many natural reservoirs for it that it would not be possible. So the big concern, obviously, is the issue around a pandemic strain developing from which the human population has no protection. We also don't want to be losing our cows. We don't want to be losing other animal species, if at all possible. So that's the real issue with this particular virus. Now, you asked how it's transmitting. Obviously, some of the early movement between cows were cows that were on wheels, interstate movement. Okay.
Yeah.
We saw this we see it all the time in the swine world. I forget, there's estimates of 600,000, a million pigs on wheels every 24 hours in the United States. They might be going from one state where they were born to another state where they're being finished out, and to our favorite bacon and pork chop, or Christmas ham. So there's a lot of animals that are moving all the time from point A to point B. and some of them they're going from the finishing house to the slaughterhouse for harvest. So that's a normal process. But at the beginning of this outbreak, there were animals moving from one state to the next. In the early parts of the outbreak, unless they had mastitis, nobody recognized that they really had a clinical illness because it was mild if they weren't lactating. So sometimes animals that were infected but not clinical got moved from state A to state B, and that was the cows on wheels. Now there's a paper that scientists at NEDC have submitted for publication, and part of it is available on a preprint server that I've read. And with that sequencing effort, they know that the genetic analysis pretty much of all these viruses started at a single point in cows, and it spread from there. So the good news is that USDA, the federal orders came out to have all cattle tested before interstate transport. So of the recent period since that order went into effect, there's been much less movement into new herds, and so that's good. And people can test before they move in between herds. That would be ideal, and we'll touch on that maybe later. But at this point,
Okay.
They've analyzed the genetic sequences of over 1,200 H5N1 sequences from this recent outbreak, and they know that there's not been any emergence of what they consider genetic sequences that would predict good adaptation to mammals in general. So that's the good news. However, as an RNA virus that goes under continuous evolution through mutations and antigenic shift, when it replicates on a new host, Mother Nature's really good at, having things survive. And I wouldn't put it past Mother Nature for something to eventually happen if we don't get this under control in cattle. So,
okay.
Now, one of the things that's important here is that continuous surveillance and the ongoing research that everybody's still trying to do to monitor all the developments that are happening, because they do indeed want to mitigate any risk of a global pandemic. So that's the ultimate goal, is prevent a global pandemic. Now, I do know that in cattle, there's already research that's been done with some vaccines that looks very encouraging. But to get through the regulatory process, we can get vaccines approved fairly quickly. In 2009, I think they set the record with the H1N1 for the most rapid approval of a swine influenza vaccine in modern history. So that all happened very rapidly. So it can be done, but there's a lot of issues with the high-path avian influenza viruses that affect export markets. And so there's going to have to be a lot of what shall we say, introspection by various groups to make sure that we do not impact our export markets into countries that we have various agreements not to be sharing viruses we have. Now, that said, this virus has hit this continent. And as I talked about, these viruses tend to spread globally eventually. So I'm not wishing it on any other continent, but I'm sure they're going to be paying very close attention, and hopefully they don't get it and we can stamp this one out. But that'll be a big challenge. So,
well, yeah, especially with the way you describe the the giant incubation areas in the polar regions that everybody from all the birds from all over the world go and hang out and swap diseases and go back where they came from.
Yeah, it's a big party, isn't it?
So if I'm a dairy farmer, and at this point I am, I'm comfortable saying I am free of any effect of this avian influenza. I have no issues. What should I be doing to keep my operation free of any impact?
Well, biosecurity is the short answer. And what does that mean? And, we can provide in research a very biosecure environment. All right. You shower in, you shower out. You got double HEPA filters on the exhaust. You HEPA filter the air going into the pens where the animals are located, so they don't get exposed to anything that's being released from a semi-load of livestock that's a quarter mile away on the interstate. And we don't cross back out there because we've taken every precaution we can to prevent it shedding into the environment. Now, on a farm, particularly a dairy farm, this is next to impossible. We have beautiful large buildings that have great airflow that the cows like, but those are palaces for birds too. And keeping the birds out of those palaces, if you've ever been on a dairy farm, it's next to impossible. There's great feed sources, so keeping your feed sources free of birds would be a goal. That's probably impossible. There's a lot of things that people use. They put plastic owls, they put in screech-making noisemakers that sound like a hawk. The birds that are going in and out, they might be bothered by it for a short period of time, and then they learn, oh, that's just a piece of plastic. It's not going to eat me. So they come back. And you don't want, they put things on the boards in the roof, the rafters, to deter birds from roosting on them or nesting up there. But, the pace that work great, they tend to get on the wings of the birds, and those birds fall down, and they may end up in the feed and contaminate the feed of the cow. So you don't want that happening either. So obviously, if you see a carcass of a dead bird that's in your bunker silo, don't feed it, which I'm sure nobody would try to do that, but that's hard to see when you're using a big end loader on the large dairies. And those are real risks. The other thing is, and we know this has happened in the swine world, where there have been rare detections of other types of avian influenza in pigs. And this happened a little over 20 years ago here in the Midwest. And both of those farms, even though they were quite a distance apart and had no linkage to each other with workers or anything that worked at each farm, but they all both used surface water ponds, either to water their pigs or to wash the pens. A pond is going to be where migratory waterfowl will land, and they will shed the virus in that water. So not using surface water to water your cows or to wash down the pens in a flush system would be highly recommended, and that may cause a dramatic change for some people. So also making sure that your dry lots are sloped so they don't get standing water that would attract birds, and might also encourage cows to drink out of that standing water. You don't want that to happen because it could be contaminated as a way to infect them. So those are all things that I think are pretty obvious. The other thing, contact your local veterinarian, because your veterinarian is going to be able to get onto your premise and have eyes on the ground and identify points of weakness that you might have that you could improve on without doing a lot of extra effort. So there are things that we can do to reduce the probability, but Mother Nature is going to put up a heck of a battle against us in keeping birds out. So that's going to be the big part of the challenge in my mind. Now, in terms of protecting your workers, that's going to come down to wearing face shields, maybe, the plastic face shields that might protect against a splash. But there's going to be a lot of aerosolized milk droplets in the parlor when you're washing. And there's a lot of things out there that you can try to do to help minimize that. And I leave that up to the individuals working with their veterinarian to see what's best for their particular farm. Now, the other thing people can do is the poultry industry has been dealing with high-path avian influenza for many years. And they do their level best to keep wild birds out of their barns. And their barns are designed differently. They're a little more amenable, but I tell you, they still have challenges because birds will poke holes in their screens and they still get infections. And that's a real frustrating thing for them because, as you know, millions of birds get destroyed with high-path avian influenza. So there are websites out there that APHIS has with some guidance on how to use some biosecurity to protect your farm from high-path avian influenza viruses. If you're a poultry producer, dairy producers can take a look at that and see what may or may not apply for them because each farm is different. So you need to read these ideas. Obviously, biosecurity is key, but with these large open barns, it's impossible. So just all you're going to be able to do is reduce your risk. You won't be able to eliminate it.
And I know whether it's an Agri-King program client, we've certainly known of farms that we're working with that have been impacted by this strain of avian influenza. We've got farms that are neighbors, farms you just hear about. We have seen, I think, a general benefit to first a good overall plane of nutrition and fortification, that just keeping animals healthy will go a long ways. I mean, just like with people, you mentioned the single human fatality was, from the things I read as well, someone with some other health issues that's going to put them more at risk. We have at Agri-King a product called Trilution, which is a pre and probiotic that we've had for over 20 years in various forms. We keep improving it, that we are seeing some good results with, not because it directly impacts avian influenza, but rather it helps raise an animal's general immunity and their ability to deal with some issues. You talk some about, I'm probably going to get in a lot of trouble for this now. You've talked some about cats on farms being a modern canary in a coal mine, if you will, that could be an indicator that you have the issue. Anything else on a dairy that people have observed when their cows are being infected?
Well, certainly dead birds have been seen too, Mike. So that, now it's been reported also in raccoons and opossums. But, there's a lot of things that those animals can all die from. But if you see a mass die off, what dairy farm exists without a bunch of cats? I milked my first cow, which was an old Guernsey, when I was about 3 years old. And I got great joy out of feeding the cats right from the teat end. They line up behind you, squirt the cow, and the cats are just sitting there. And some of them are sitting there up on their hind legs, and you knock them over with the milk, and they love it, and they come back for more. So, you aren't going to get rid of your cats, but if you see a die-off, it might be time to contact your veterinarian and take a closer look at your cows, because it might be a forewarning of worse things to come when it comes to the lactating herd. And I know, Mike, that it's almost impossible to do a nutrition study in a high biocontainment environment like we have at NADC or anybody else in the world that might have. It's not a typical production environment. It's great for transmission studies and pathogenesis, meaning where's the virus at in the body. But nobody can afford to do those kind of studies because the cost of those biocontainment facilities is astronomical. So all we have are anecdotal reports of experiences that people have on their farms. And I know that Agri-King has had customers that began using Trilution on one. They had a couple of herds, and one got infected, and they started using it. The other herd got infected at a later date, but they had started using it. The second herd had a much milder impact of the virus in terms of, going off feed and lower milk production. So yes, keeping animals fed properly, keeping them eating, and supporting the health of their immune system by proper nutrition, that's something you just recognize that cows need 24/7, 52 weeks a year. So I strongly encourage working with a nutritionist to make sure your herd is at the best possible nutrition it can be for your needs and for the cow's needs, and more importantly, and certainly Agri-King has products that it's that focus in mind when the products were developed.
Marcus, I might even be able to handle a test now if there was one. That was an absolutely a wonderful both overview but detailed summary of where we find ourselves right now with avian influenza. Any parting observations you'd like to make?
Well, I just again emphasize that prevention of exposure of your herd is key here. Work with your veterinarian to see if they have recommendations that you can do on your farm. Your veterinarian will be able to stay current with what's available, what research is being done, because all the researchers try to get their information out to the veterinary groups and commodity groups as quickly as possible. So always consult with your herd veterinarian about what you should do on your farm, because they're another set of eyes that can help you see your vulnerabilities. Don't bring untested animals into your herd. That is just asking for problems, and the problems go way beyond high-path avian influenza if you don't test animals for certain diseases before you bring them in. BVD is a great example of you don't want to bring that virus into your herd because you can have a whole long series of health issues with BVD virus that will take you a long time to recover from. So always good biosecurity when you're introducing new animals into your herd. And make sure that you're paying real close attention and catching the first signs if your herd does get infected. So you catch it in your vet, and you can respond in ways that you hope will reduce the severity of the episode.
I want to thank you, Marcus, not only for the time you've given us today. I'm very impressed by the diverse talents that are on our board of directors, and it's a real asset to the company. There's a very diverse group, financial experts, people like yourself, that I think helps Agri-King help our people and do a better job for our clients and for the industry. Now, Chris, you're probably going to need a long time. I always ask you at the end of this, what did you learn? You go ahead and start through your notes now and bring us up to speed with what you picked up.
Hey, my big takeaway, Dr. Kehrli, you were super passionate, and I love that excitement. And like Mike said, how you help us out has got to be incredible. My big takeaway is that I guess something we always talk about is how the world is growing smaller and smaller, but it's been the birds and their stinking parties apparently that are bringing us even smaller and smaller with their diseases as they travel around the world. Now I'm fascinated that is like a party of birds is what's affecting us in Iowa or Illinois or, and all over the country. Just that's incredible. But Dr. Marcus, thank you so much for your brain and your intelligence. And that's just your time of sharing your story. That's incredible. If you like what you heard or you like what we were talking about, hit us up on any of our socials. If you have any questions or comments that you'd like us to discuss any further, you can email us at podcast@agriking.com. Dr. Kehrli, Mike, thank you so much for your time.
Hey, thank you both. Appreciate it.
Great. Had a good time. Thank you, all.